Welcome to our video on ocean acidification, the unseen threat to marine life and human livelihoods. In the coming minutes, we'll explore the alarming impacts of rising carbon dioxide levels on our oceans, highlighting the risks faced by calcium-building organisms and the imminent collapse of coral reefs. We'll also discuss how these environmental changes affect fish populations, threaten food security, and lead to significant economic losses in fisheries and aquaculture. Finally, we'll outline the urgent need for global carbon dioxide reduction to safeguard both marine ecosystems and human livelihoods. Join us as we delve into this critical issue that affects us all. 1. Calcium-building organisms are at risk. The increase in ocean acidity is particularly troubling for organisms that rely on calcium carbonate to build their skeletons and shells. Corals, shellfish, and certain types of plankton fall into this category. In more acidic waters, carbonate ions, which are essential for these organisms, become less available. Imagine trying to build a sandcastle without enough sand. The structure would be weak and unstable. This is precisely what happens to marine organisms as they struggle to maintain their structural integrity in increasingly acidic environments. This disruption not only affects individual species but can ripple throughout the entire food web. 2. Coral reefs face collapse. Coral reefs, often referred to as the rainforests of the sea, are under significant threat from ocean acidification. As the acidification process weakens these vibrant underwater ecosystems, the biodiversity they support is at risk. Millions of people worldwide depend on coral reefs for fishing and tourism. The collapse of these ecosystems could lead to the loss of livelihoods for those who rely on the ocean's bounty. Like a domino effect, the weakening of coral reefs can lead to broader environmental and economic consequences that extend far beyond the ocean's depths. 3. Fish populations are affected. Fish are not immune to the adverse effects of ocean acidification. Acidified waters can disrupt the sensory abilities of fish, affecting their ability to navigate, avoid predators, and reproduce. Picture a world where birds can no longer find their way south for the winter. Similarly, fish find themselves disoriented in acidified waters. This disruption can have cascading effects on marine populations, as fish struggle to survive and reproduce, potentially leading to declines in fish stocks and further destabilizing marine ecosystems. 4. Economic losses in fisheries and aquaculture. The economic implications of ocean acidification are profound, particularly for the shellfish industry. Acidic waters make it increasingly difficult for oysters, clams, and mussels to grow, posing a direct threat to global seafood markets. As these industries struggle, so too do the communities that depend on them for their livelihoods. The economic losses could be staggering, affecting everything from small coastal communities to international seafood trade. It's a stark reminder of how deeply interconnected our world truly is, with the health of our oceans directly impacting human economies. 5. Food security is threatened. Ocean acidification poses a significant threat to global food security. As marine food chains are disrupted, fish stocks dwindle, endangering the primary protein source for over 1 billion people worldwide. Many communities, particularly those in developing nations, rely heavily on seafood as a staple of their diet. The decline in fish populations could lead to food shortages, increased prices, and greater competition for resources. This potential crisis underscores the serious implications of ocean acidification, emphasizing the need for immediate action to protect both marine life and human communities. 6. Solutions require global carbon dioxide reduction. Combating ocean acidification requires a coordinated global effort to reduce carbon emissions. It's akin to stopping a leaky faucet. Without addressing the source, the problem will only continue to grow. Conservation efforts, such as protecting seagrass and mangroves, which naturally absorb CO, are essential. These natural buffers can help mitigate the effects of acidification, but the ultimate solution lies in reducing our carbon footprint. Collective action and commitment to sustainable practices are crucial in preserving the health of our oceans and, by extension, our planet.